Hello and thanks for joining me. Well, today we're going to build a differential, kind of, for my buckboard flyer. And the purpose of a differential is to let one wheel move faster than the other while both of them are being driven. And the reason you need one wheel to move faster is in a turn, the outside wheel in a turn moves considerably faster than the one on the inside. And without that, it resists turning, at least on the street. On a dirt track, you don't really notice it, but to some degree on the street, it makes it difficult to steer. But I'm kind of having a different problem with my buckboard flyer because it's one-wheel drive. Under acceleration, it wants to turn to the right, and when I let off the gas, you got to correct back and turn to the left. So it's tolerable, and I can compensate for it, but it's really not right. So I need both wheels to drive at the same time. Well, differentials are fairly large in diameter, and I didn't want to make the room for it. So what I'm going to use is something called a Sprag bearing. And a Sprag bearing, or a Sprag clutch, I guess that's the real name, a Sprag clutch, is a one-way bearing. In other words, it'll turn this way, but it won't, the inner race won't turn the other way. Only one way. Pretty cool bearing. But the torque rating for one bearing or two bearings, actually the torque rating for one bearing is exactly the same, or really close to the same, as the torque on the sprocket on my, at least the way I got it figured, the torque on my sprocket with the 6.5 horsepower motor. So I'm going to use doubled bearings, so I'll have twice the strength on each axle. Potentially, you could get a full 6.5 horsepower on one wheel. So I had to account for that. And if I did my math right, I'll have double the strength. What I'm going to do, this thing here, this is what we're going to build today. It's got some machine tubing, bolt circle here, a flange. We're going to build that today. But it's going to have a bearing inside right here and a bearing right here. Same here and here. Of course, it's got to be oriented correctly so that it'll drive forward. And then essentially what it'll do when you let off the gas is coast, just like a bicycle would when you stop pedaling. Of course, the only drawback to this is that you don't have a reverse. Well, I don't have a reverse on the buckboard flyer anyway, so it doesn't matter. Anyway, this is what we're going to build today. I had a couple of problems during the making of the video. I assumed the inside ID was concentric to the outside OD of this machine tubing, the DOM, and it was not. It was probably 20 thousandths off. So I corrected that midstream and it worked out okay. But at the same time, I couldn't really explain, well, I was explaining what I was doing, but my microphone quit. So there's a portion in the video that's just video, and I can't talk and explain what I'm doing. But everything else went really smooth, and I'm really tickled with the outcome of this so far. Next week, this is part one here. Next week I will cut the bearing fits and a keyway. See, this thing's got a key on the inside and a key on the outside. And I'm not really sure how I'm going to cut that key in there, but I got a few ideas and I think it'll work out. So let's get started. Here's another drawing of the two pieces. It's going to have like a flange, and the sprocket will fit over that little lip right there. So I got to make those two flanges that bolt together first. Okay, you just saw me make that in the lathe, and that's to fit the existing hole in this sprocket. And I used a spotting drill, which carbide spotting drill, and you really shouldn't, you should use them not to drill clear through, but one aspect that's unique about the spotting drill is It's not got any relief on the outside. So it makes a fairly true hole, which is what I wanted. I'm going to use it as an alignment pin. First thing I'm going to do is drill 2 1/4-inch plates and that'll be our bolting flange. And then I'm going to lay this on top and use this drill as an alignment pin so that I can bore the sprocket and these 2 rings, that's what they will be anyway, with a larger hole and do them all at once. And I'll use the same setup for using my boring bar to bore all 3 at once. And I'll use the same setup for making my bolt pattern. Now I've got my DROs zeroed, so if anything gets moved, I got the tables locked. Make sure they're good and locked. Now I'll bore the 2 plates out larger, and then use my boring head to enlarge all the holes to 2 1/4, I believe, or 2 1/2. Well, I'm going to have to change belts on my mill. I can't get enough speed, or I can't get a slow enough speed because I lose power. Okay, I changed belts. It should be a lot better. Oh, for sure. Just changed the insert. I believe it's going to work a lot better now. It was doing pretty good anyway, but yeah, that's not breaking chips is good, but cutting a lot smoother. Okay, I've got my bolt pattern set up on my DRO. I made a tutorial on that and another video. I'll post a link to the tutorial in the description. But I'm going to go through, I've only done it a few times, so I'm going to go through and just peck the surface of it and make sure the locations look right. It's a lot of work, but I don't want to get this wrong. Well, that's probably hard to see on the camera, but that looks right. So I'm going to go ahead and drill. Okay, here's the real test here. The real test is if they line up in all positions. Perfect. Now I got to grind the mill scale off of this because I'm going to be welding that. Check this out. A friend of mine, Haas Anderson, made this tool for me. And it's pretty useful sometimes. Check this out. It's fairly amazing if you ask me. Straightens it right out. Last week's video, or 2 weeks ago, I made bearing fingers for my steady rest. Okay, first thing I'm going to do is face the end of this off accurately. Okay, now I've got to cut a little ledge right here. And what that's for is for this to fit into. So I need to measure the diameter. It needs to be a good fit. I need to measure the diameter of that. .236. It hits 0. When I measure this, it will tell me how far I need to go. Okay. 0.343 divided by 2. 0.343 divided by 2 equals, I need to go 171 thousandths from the center out. The depth of this is not critical. The depth going toward the chuck. Should be a good fit. That's a perfect fit. But what I got going on here is this ledge and this ledge together got to be the thickness of that sprocket. And they're not yet anyway. So I need to take that off just a little bit right there. Yep, that's it. Okay, the moment of truth. Let's see if it wobbles. Wow. I'd say that's a good one. I'd say we're good to go. Now, I've got to cut bearing fits on both ends and keyways. And the bearing fits are going to be tedious. But I have no idea, well, I got an idea how I'm going to do the keyway. It's going to be kind of a pain though. Yeah, it turned out good. Well, that about wraps it up for today. Join me next week and we'll cut these bearing fits in there and maybe get a good start putting it in the car. Anyway, be sure and subscribe and ring that bell.